Welcome, one and all. I am Mrs. Banani Ghosh, Assistant Professor in the Department of Information Technology, Haldia Institute of Technology. Today, I am going to present a video lecture on relational data model. In this video lecture, I will be trying to cover up these topics: structure of relational databases, database schema. Then I will be elaborating on keys. After that, I will be showing the schema diagrams and relational query languages, and I will be concluding the session with relational algebra. Now, coming to the first example of the relational data model. So what is the relational data model? Let me briefly recapitulate the data model concept, and for the convenience of the students, I am using the readily available slide of Korth, very much popular to all of us, and you can find it in the internet. It is freely available. So if you recapitulate the concept of data model, what is data model? Basically, data model is the representation of the database. So what is database then? So database is a collection of interrelated data. And to represent the database, we actually use separate data models. The thing is that one particular database can be represented in terms of different data model concepts. So what are the popular data models available? Relational data model, entity relationship data model, object-oriented data model, network data model, etc. Now coming to the relational data model. If you are taking the example of this particular instructor relation, then you can see that the name of the table is the name of the database. And what about the structure of this particular database? In case of relational data model, the main concept is that the whole entire database is represented in terms of tables. So by the term table, automatically two things are coming in our mind. One is that the table is comprising of several rows and several columns. What about the rows and columns of this particular table? Individual attributes. Attributes are what? Attributes are the characteristics of the entities. Now, entity name is same as the relation name. So here, what is the entity for which the database is made? It is the instructor entity. And instructor entity is having 4 characteristics. These are called the attributes. So in the table or tabular representation or the relational data model representation of the database, you can see that in the column names, the attributes are written. And what about the rows? The individual rows are the individual instructors and their data, interrelated data. So what about the individual rows? It is having separate tuples in it. So one individual instructor is having its record in a row, another is having in the next row, or another is having in the next row. In this way, the entire table is built up. So what is the gist of this particular concept? The attributes are placed as the table columns and the rows are depicting the tuples, individual tuples. Now coming to the next slide. What about the relation schema and instance? Suppose the attributes are represented as A1, A2 up to AN. So a relation R, if it is represented by capital R, is equal to, it can be written as a collection of attributes A1, A2 up to AN. So for example, instructor can be written as instructor equal to ID, name, department name, and salary. In this way, the schema is represented. So our relation instance small r defined over schema capital R is denoted by small r of R. The current values of a relation are specified by a table. An element small t of relation small r is called a tuple, means the entire row, and is represented by a row in the table. Now attributes. The set of allowed values for each attribute is called the domain of attributes. So what about coming to the example we have presently encountered? It is the instructor relation. Now, if you concentrate on this particular ID field, there you can see the entire so instructor fraternity are having the ID as a numeric field. It could have been an alphanumeric field, but for this particular table, it is numeric. And moreover, if we concentrate more, then we can see that it is comprising of 5-digit numbers. So it is number and it is of 5-digit. So, the domain of all attributes of ID must be having numeric field, and moreover it is limited up to 5-digit number. So, it is called the domain of the attributes. Attribute values are required to be atomic, that is indivisible. So, you cannot it is not practicable to have more than one ID or more than one name for a particular tuple. It should not be there. You use a separate row for writing that separate entity. But the thing is that in a particular row, every attribute value must be atomic. So single value, indivisible, which is not divisible, must be there as the values of the attributes. The special value null is a member of every domain, indicated that the value is unknown. So it may happen that in several cases we will be encountering the value null as the attribute value. So what is the meaning of that? It is having a special meaning. What is the meaning? The value of that particular attribute is not known right now, but in future it can be known and it will be updated. So, the null value causes complications in the definition of many operations. Why it is told? Because if you operate on null values, if some value is added with the null value, the result will obviously be null. And if it will not be giving you the concrete result. So, it makes the complication in definition of many operations. Now coming to the relations, a relation in a relation or a relational data model, you can see that the data which are inserted into the table is not sorted. So unsorted data may be may be populated in the database. Why unsorted data? Because if you are waiting always for the sorted data to come, then the database will remain incomplete all the way. So you have to maintain the thing that whenever and whatever data is required to be put into the database, it is to be put into the database. You don't have to bother about the ordering of the data you are going to insert. Now, database schema. What about database schema? It is the logical structure of the database. So, if you are talking about the instructor relation, then it is having the ID, name, department name, and salary as the attributes. So, it is the schema which is telling us about the structure of the database. And what is instance? Instance is the data residing over there in the database at a particular moment of time. So there is a difference between the schema and the instance. Now we are coming to a very important concept, key. So what is key? Key is nothing new, but it is an attribute or a separate or a group of attributes which will be helping us to uniquely identify a particular tuple from among the group of tuples in the relational data model. Now, let R be a subset of K be a subset of R. So, K is the key and K is a super key of R if values of K are sufficient to identify a unique tuple of each possible relation r of R. Example, ID and ID name together are both super keys of the instructor. Now, coming to this particular example, you can see that for the ID field, each and every tuple is having unique value for it. So, with the help of this double two triple two ID, you are identifying a particular instructor and which is working in a specific department and who is earning this much salary. So, a particular instructor from among the group of instructors can be identified by the ID. Now take the ID and the name together. So think about 45565. It is the ID and the name is cats. So together they are creating a new combination of uniqueness. So this is unique combination 45565 cats is the unique combination through which you can identify one and only one tuple from among this group of tuples. So this is going to be ID and ID comma name together. They both are super keys. So super key K is a candidate key if K is minimal. Now from among these two super keys, which is minimum? ID is minimum because it is comprising of only one attribute in it. Here you can see there are two attributes in it. So the candidate key will be the super key. Super key K is a candidate key if K is minimal. So which one is going to be the candidate key? ID is obviously going to be the candidate key for the instructor table. One of the candidate key is selected to be the primary key. So you can have a number of candidate keys. From among you have to choose one. So who will choose that? The database administrator is there to choose that from among the alternatives of the candidate keys, which is to be selected as the primary key. So it is the responsibility of the database administrator. Now coming to the foreign key constraint. Why it is called constraint? Constraint means a particular row or a particular column, that is the attribute value, is having some set of rules applied to it. For that it is going to be special. So what is foreign key? In case of foreign key, one table will be having it as a simple field, and in another table it is going to be the primary key. Now in the format table it will be called the foreign key, and in the table in which it is the primary key, it will be creating the connection in between these two tables. So it will be referring one relation, one will be called referencing relation and one is called referenced relation. Now relational query language. There are two types of query languages. One is procedural and another is non-procedural or declarative. So by that name procedural query language, you can have a brief idea about that. Let me elaborate. What is procedural query language? In case of procedural query language, what is the basic objective of query language? Why it is written? The basic idea or objective of writing a query language is to retrieve some data which is residing over there into the database according to the need of the user. So this is the objective for both the procedural query language and the non-procedural query language. But in case of procedural query language, what data are to be retrieved is clearly mentioned, and the procedure to get that data is also clearly mentioned. So that's why it is called procedural query language. And in case of non-procedural or declarative query language, the data which is to be fetched, which is to be retrieved is clearly mentioned because it is the objective. But the procedure to get that particular data is not mentioned. So it is called non-procedural. By the name, it is quite clear right now. So what are the pure languages? Relational algebra, tuple relational calculus, domain relational calculus. Now, if you concentrate on relational algebra, then you will realize that Relational algebra is procedural. Why? Because the entire procedure to reach up to that particular data is clearly mentioned in the relational algebraic expression. But in case of relational calculus, in the expression, the data which are to be fetched is clearly mentioned, but how to get that data is not mentioned. So it is non-procedural query language. Clear? Now coming to relational algebra. Relational algebra is basically a collection of operations. So what are the operations? The basic operations are 6 basic operations are there. You can see select, which is defined by sigma, then project, which is implied by this pi symbol, union, traditional union symbol, set difference minus symbol, Cartesian product cross symbol, and rename is the row symbol. Now coming to the first operation, that is the select operation. The select operation selects tuples that satisfy a given predicate. Now a new term we have come with, that is predicate. What is predicate? Predicate is something like a condition. So whenever you are going to fetch a data, you must have some condition in it. Otherwise, how you can retrieve that data, and you are not considering all the data. So you are retrieving some of the portion of the data as because it is satisfying some conditions. Yes or no? So the predicate will be having clearly the condition which is sufficient to get that data. So P is called the selection predicate. How it is represented? Sigma P small r. So small r is the name of the relation or instance of the relation on which the sigma operation is to be run. And what is the selection predicate? That is the P. Now in case in the place of P, you can have separate conditions in it. Here you can use the logical operators, relational operators, equal to operators, everything. How it will be used, I will be elaborating in some few slides. So now coming to the first example. If we are interested in fetching all the instructors details who are working in the department name physics, what we will write? So our objective is to retrieve the data, entire data about the instructors. So instructor table is important. Now, what is the condition? They should work in the physics department. So how to write that query? How to write that relational algebraic expression? You will be writing the sigma operation. Then after in the selection predicate, you will write what? The condition department underscore name is equal to physics. As it is a string, it is to be enclosed within double quotes. Now, on which table it is to be run? On the instructor table. So now if you go to the original table, you can see that in the physics department you are having two person. One is this Einstein and another is Gold. So coming to this, you can see only 2 rows are fetched. So it is our ultimate objective. Now in case of this selection predicate, you can use all these operators. Why? Because it may be needed that you have to amalgamate 2 or more conditions. So in case of that, the logical operators and the relational operators will be of help. Now, if you take the example, find the instructor in physics with a salary greater than $90,000. So what are the 2 conditions here? One is that the department name must be physics and the salary must be greater than 90,000. So how to write it? Sigma department name is equal to physics and operator. It is and, see, and then salary greater than 90,000. On which table it is to be run? Instructor table. So it will be giving you the result. The tuples are who are working in the physics department and earning more than $90,000. Okay. So in this way, you can carry on the selection operation. So one thing is clear to us, that whenever you are using the selection operation, the thing is that the entire row is selected. So selection operation cuts the entire row. It is to be remembered. Now coming to the projection operation. So in case of project operation, the unary operation that runs its argument relation with certain attributes left out. So how to write it? So, pi, then after a1, a2, a3, ak, and r, where a1, a2, ak are the attribute names and r is the relation name. The result is defined as the relation of k columns obtained by erasing the columns that are not listed. Now, coming to the example. See, if you are interested in fetching the ID, name and salary from the instructor table, so what operation you will be using? See, you are interested in cutting all the attribute values. So whenever attribute values are to be fetched, then you are going to use the project operation. So project, then after list up all the attributes separated by commas, and then after the name of the table on which it is to be executed. So you can see in the new table, the ID, name and the salary, which are specified in the projection operation are fetched. Clear? Now the composition of relational operators. So how you can amalgamate or club together more than one operations. See, if you are interested in fetching only the name of the instructors who are working in the physics department. So because you know this part, select operation, then department name is equal to physics. So it will cut the entire row of the instructor who are working in the physics department. Now from that particular thing, you have to cut what? You have to cut. So the result is this one. From here, you have to cut only the name. So now you are interested with one particular column. So projection operation is to be you applied. So projection, name, then after you put a bracket, inside that the sigma operation is to be written. So as we know that bracketized portion will be executed first. So at first it will be giving the two rows which are having physics as the department name. Then after the names will be cut. Now Cartesian product. As per the concept of the Cartesian product, we already having the Cartesian product does the same thing. Here also, here the Cartesian product is denoted by cross symbol and it is a binary operator. It needs two tables to act on. So instructor cross teaches, if it is considered as the Cartesian operation, then what it will be doing? It will be combining, it will be creating the combination of all the first row of instructor table with all the rows of in the teachers table, second row of the instructor table, and the combination of all the rows in the teachers table. In this way, the entire table will be built, which will be a bigger one. But in some cases, it is required to have the Cartesian product of two tables for specific purposes. Now, coming to the join operation. Now, join operation does what? Join operation also does the similar thing, but it is not exactly same with the with the Cartesian product. So, in case of join operation, you can have the join operation allows us to combine a select operation and a Cartesian product operation into a single operation. So it is a collection of two operations. So what are the operations? Selection operation and a Cartesian operation. So how to write it? See, R join operation, it is the condition theta S. So these are the two tables R and S which are to be joined. Then after, it is the joining condition over here. Joining condition means two of the tables will be having the same attributes. So here the foreign key concept is used. Then after, it is equal to what? Sigma of theta R cross S. Now we are coming to the union operation. Now union operation is basically represented by the traditional union symbol, and it is if we are going to have the union operation of the relations small r and s, then we will write what? R union S. R union S will be valid if and only if R and S are having same number of attributes. If R and S are having different number of attributes, then the union operation will not be possible. So what it is called? It is called it must have same arity. Arity means same number of attributes. Then after the resultant table will is also going to be a table. The attribute domains must be compatible. So now see, to find all courses taught in fall 2017 semester or in the spring 2018 semester or in both, how to retrieve them? So you have to do what? You have to fetch the course ID. So course ID you are fetching ultimately, and from at first you are doing what? Sigma semester equal to fall and year is equal to 2017. It is run on the section table union. The same thing is done with the spring and 2018. So you will be having the course IDs which are taught in fall 2017 and the course IDs which are taught in spring 2018 or both. Now, this is another example of union operation. If you go through this, it is very easy to understand. Now we are coming to the set intersection operation. So what is set is the intersection operation? It is represented by this notation R intersection S, where R and S are two separate tables with same arity. Same arity means number of attributes are same and the attribute of R and S are also compatible. These are the two conditions which are to be fulfilled to have these set related operations. So coming to the example, find the set of all courses taught in both the fall, mind it, both the fall 2017 and the spring 2018 semesters. So same thing is to be done, but the operation will be the intersection operation, as we know already with the set theory knowledge. Now it is depicted like this. Now coming to this assignment operator. What is the use of assignment operator? Assignment operator is basically used to have the names of the intermediate tables. What is the need of intermediate table? Suppose a particular relational algebraic expression is having more than one operations in it. So in between whenever one particular operation is executed, then after we can think about that it is assigned in a temporary table. Suppose this is the find all the instructors in physics and music department. So you have to find out the names of the instructors who are working in the physics department and in the music department. So ultimately you have to do what? Sigma department name is equal to physics and instructor. Now you are you are assigning the particular smaller number of rows in physics table, and similarly you are doing the same thing with the music department. Now department name, and you are assigning it to the music table. Now ultimately to get the entire result you are doing what? Physics union music. So here it is the assignment operator in which arrow which is left hand headed is used to have the temporary kind of tables. Now the rename operations. How the rename operation is denoted by the row, and it is the results of the relational algebraic expression do not have a name, and that can be used further. So rename operation is used for this particular purpose. It is not of so much importance. Now proceeding to the equivalent queries. See, equivalent query, there is more than one way to write a query. So find information about courses taught by instructors in physics department with salary greater than 90,000. It can be written in with the help of this single sigma operation. This can be written like this, and this can be written like this also. So the queries which are not identical in appearance, but they are giving the same result is going to be the equivalent queries. So here also, if you are joining this instructor table and the teachers table with the help of instructor ID is equal to teachers ID, it is the common field in between these two tables, and from there you are fetching the department names which are physics. And here also you are doing the same thing, but you are doing what? First of all, you are fetching the names, all the tuples which are having physics as the department, and then after you are doing the joining operation on the basic based on this particular joining condition. So these are the two equivalent operations which are written in two different ways. So in different use, a particular query or a particular requirement may be served using the relational algebraic expression, different relational algebraic expressions. So it is not mandatory that this is the hard and fast rule, but the basic criteria must be fulfilled. The basic things must be maintained, but if it is giving the result by correctly executing the sequence of operations, then it is going to be the equivalent queries. So in the next session, so we hope that we will be elaborating on relational calculus, and for the time being, let us end up with the class. And if you have any query, you are having your my email ID and phone number, you can contact me, and I will be there with my with whatever you need. Thank you.